Hi everyone, welcome to our discussion. In this video, I will be discussing or talking about the topic data collection and presentation. So data collection and presentation is a very important topic since this is applicable in almost all fields of study. It can be applied in education, in engineering, in information technology, in accountancy, in almost all of fields because in everything that we do or in every field, there will always be a spot or a place for research. So let's start by defining what data collection and what data presentation is. So as per definition, collection of data refers to collecting information about something with an objective to analyze it or extract some meaningful information from it. Meaning, collection of data is merely gathering of data. And with you or if a person gathers data, there should be a purpose behind it. It should be analyzed, utilized, and make use of in the end. Now, on the other hand, if we say data presentation, it is defined as the process of using various graphical formats to visually represent the relationship between two or more data sets so that an informed decision can be made based on them. So after gathering, collecting the data, data presentation will follow. So data presentation comes in many forms and there are many ways of presenting data, which I will be discussing in the next few slides. So just to give you an idea, it can be graphical in format, it can be textual, it can be tabular, and so on. So here are some examples of activities involving the collection and the presentation of data. So this should be, I'm sorry, presentation. So first example is students collecting data from their localities about the number of people with COVID vaccine. So suppose your teacher in research or in science instructed you to collect this information about the number of people who were already vaccinated. There are actually many ways to do this. You can go to the barangay. You can ask for that certain data. Of course, proper with the proper format. Like you will be asking for permission. You will be giving a letter. But in terms of collecting data, yeah, you can ask the barangay. You can go to the DOH, the Department of Health. You can also check online websites, online resources. And if you want to go the extra mile, you can actually um, visit every household and ask them whether or not they are already vaccinated. Second one is a football fan collecting information about the goals scored by his favorite player. So suppose you are a football fan and you idolize a certain player. So during the game, while the teams are playing, you can observe your favorite player and then you can like tally or take note as to how many times that certain player was able to get a goal or kick the ball so that it will hit the goal. Third one is a record company collecting information about album sales by their artists. So this is done by a certain company so that they will know whether the album is gathering or giving them more sales. So this can be done by assigning some employees or assigning some people to collect this certain information. So they can call the stores wherein the albums were sold. They can ask them as to how many sales have been done so far since the album was released. So these are just some examples of data collection and presentation. So these are below various ways wherein we can present data that has been collected. Now, in terms of data collection, there are two types. We have primary and secondary. If we say primary data collection, data is obtained directly, take note, directly from the source of information. So how can you do this? You can personally ask someone through a face-to-face interview. You can do this via phone call, through the telephone or your cell phone. You can do this via live video call or video chat. You can also do this by giving a questionnaire. A questionnaire is uh, like a test. It is in the form of it is in the written form or printed form. So you can ask someone to accomplish or answer that certain questionnaire. So that's also primary data. As long as you're able to get or collect the information from the source. So that is primary. Next is secondary. So if you say secondary data, this is obtained or data obtained that have been previously collected by another person or institution from some other purposes, taken usually from publications or existing records. So secondary data meaning data obtained not from the primary source. So let's say, for example, you read a certain book and you quoted that certain author. So that is secondary data. If you like went to the barangay, you asked for a certain information or a certain type of data which they have collected. So that is also secondary data. So next we have the methods of data collection. So there are different types or ways on how we can collect data. The first one is what we call as the experimental method. In experimental method, data are collected under controlled conditions. If you can still remember, whenever you do science experiments, there is what we call as the independent variable, the dependent variable, and the controlled variable. So these three variables will be observed so that in the end, the researchers or you students will be able to come up with a conclusion. Second one is observation method. Data are collected by recording the behavior at the time of occurrence. So in observation method, we will be making use of our senses, our sense of sight, our sense of touch if needed, our sense of hearing, our sense of smell, our sense of taste if again if needed. So observation method is using our senses, observing a certain event, a certain happening, or certain behavior at a certain time. Third one is survey method. Data are provided by identified respondents either by personal interviews or by mailed questionnaire. So this is what I have told you earlier. Survey, you will be given a questionnaire and you will be asked to accomplish or answer that certain questionnaire. Usually in surveys, there are already options. You just simply have to choose. So for example, let's say a survey on shampoo brand. So you will be given the option, like for example, cream silk, Dove, Pantene, and so on. Then you will just simply check whether or which of those is your preference. So surveys, aside from printed surveys, there are also surveys online. Like they can be sent through mail, or I don't know if you have encountered this one, like through Facebook, there are certain ads, surveys that are in the form of ads. So you will be asked, have you seen a commercial about this one? Yes or no, maybe. And it's also in YouTube. So whenever you play videos, in between, there are certain ads, and there are also surveys in between those ads. Fourth one, before I proceed with the fourth one, okay, going back to survey method. So this is very famous in social media nowadays. In the previous days, weeks, since it's almost election date, and there are a lot of surveys as to who your preferences in terms of candidates running for president, vice president, senators, and other spot or other election posts. So next, we have a use of existing records. So data are collected from published materials like reports, personal files, historical records. So this is another way of collecting data wherein you just have to base your data from existing records like reports, personal files, and historical records. So let's say you want to know the population in a certain barangay or a certain municipality or city. So you can ask for that certain data because there are already existing records for that. So in relation to the elections, which is fast approaching, so you can also ask as to how many voters there are in a certain barangay, in a certain municipality, or in a certain city. Next, we have methods of data presentation. So earlier, those were the different methods in data collection. Now we have methods of data presentation. We have three: textual, tabular, and graphical method. In textual, it presents data in narrative form to describe the data. So from the word itself, text, meaning data is presented through words in paragraph form. Next is tabular method. Presents data in condensed form by arranging them systematically in rows and columns. So from the word itself, tabular, meaning data is presented in a table. And I know that we're already familiar when we say table. So a table, not a material table, but a table. So a table is composed of certain rows and columns, and the data is being arranged systematically. Third one is graphical. So presents data in pictorial form. So and is designed and constructed to attract and hold attention of readers. So when we were or you were in elementary, this is the most common way of presenting data in terms of graphs because it's more attractive. It catches the attention of people and readers. So we have here an example, presenting data with texts. So highlights of the data are mentioned in textual presentation. Numerical measures that summarize the data, such as mean and standard deviation, can serve as highlight. So observe how data is presented. So various colors are being used to emphasize these data. And below each country, there is a certain description in terms of words, texts, and paragraphs. Next is presenting data with tables. So a statistical table that can be constructed to present data collected is the frequency distribution table. So in data collection, this is what we are gonna be using, the frequency distribution table, or more commonly known as the FDT. So what is a frequency distribution table? It is a tabular arrangement of data by grouping the values into mutually exclusive classes and showing the number of observations falling in each category. So there are two types of FDTs, or frequency distribution. The first one is what we call as the ungrouped frequency distribution. The distinct values are used as categories or classes and with its corresponding frequencies. This is useful for data where the distinct values are few and usually used for qualitative types of data. So in ungrouped frequency distribution, data is being treated individually from the word itself, ungrouped. From the word itself, ungrouped, meaning the data are not being grouped but being treated again individually or one by one. So here we have table 1. This is a frequency distribution table for blood types of 25 patients afflicted with certain disease. So we have here the categories, the different blood types, blood type O, A, B, and AB. And on the second column, we have here the number of patients that were affected with a certain disease. So there were 7 people with blood type O who were affected with a certain disease. For the second row, there are 6 people with blood type A who were affected with a disease. Third row, there are 7 people with blood type B who were affected. And last row, we have 5 people with blood type AB who were affected with the disease. So this is ungrouped. So each category is being shown. Table 2, this is an FDT for number of cars owned by a sample of 30 families in a certain residential area. So in the first column, we are given the number of cars owned by each family. It can be 0, 1, 2, 3, and 4. And the second column, we are given the number of families. So if we analyze the table, so there are 12 families with no car owned. For the second row, there are 6 families with 1 car owned. There are 7 on the third row, 7 families with 2 cars owned. Fourth row, there are 3 families who owns 3 cars each. And on the last row, there are 2 families who owns 4 cars for each family. So notice how each category is being presented individually. So next is we have the group frequency distribution. This is used for large data sets, whereas for ungrouped, it is used for data set where the distinct values are only few. Going back, the mutually exclusive classes are in the form of intervals. So if we compare to ungrouped, for ungrouped, the individual categories are being shown. But for group frequency distribution, the intervals or the categories are being grouped in terms of intervals. Next is the group FDT is usually used for continuous quantitative types of data. So table 3, we have the FDT of the distance traveled in kilometers from warehouse by 25 delivery trucks of a certain company. So in the first column, this is the number of kilometers traveled by certain delivery truck. So for the first row, the interval is 50 to 54 kilometers. Second is 55 to 59. Third is 60 to 64. Fourth is 65 to 69. Last is 70 to 74. So again, notice that the data are being grouped in terms of interval, whereas for ungrouped, each category is shown individually. Now, if we analyze the table, there are three delivered trucks who were able to travel 50 to 54 kilometers from the warehouse. Second one, there were seven delivery trucks who were able to travel 55 to 59 kilometers. Next is we have nine trucks who were able to travel 60 to 64 kilometers. Fourth one is there were five trucks who were able to travel 65 to 69 kilometers. And lastly, there was only one delivery truck that was able to travel 70 to 74 kilometers. So here we have the steps in constructing a frequency distribution table. So step one, determine the range denoted by the uppercase letter R, where R is equal to the highest observed value minus the lowest observed value. So simply look for the highest value or the highest data, then subtract it with the lowest value or the lowest data. Step two is determine the number of classes, which is denoted by K. I'm sorry. The formula that's wrong. It should be K is equal to the square root of n. So simply look for the square root of n, where n is the number of observations or cases in the data set. So take note the value should be rounded off to the nearest whole number. So suppose there are 50 data or 50 numbers or 50 values in a certain data set. So simply look for its square root. Third step is calculate the class size or class width denoted by C. So class size is the difference between two consecutive lower or upper limits, or the difference between the lower and the upper true class boundaries. So for the formula, we have C is equal to R, which is our range earlier, divided by K, which is the number of classes. Take note, the value of C should be rounded up to the nearest number that has the same number of decimal places as the raw data. So you will understand that later on. If the data set is composed of whole numbers, so your class size or class width should be rounded off to the nearest whole number. If there are two decimal places, if there is one, so that should have the same format with the class size or class width. Fourth one is enumerate the classes or categories as follows. The lowest class must include the smallest observed value. So after determining the number of classes and the class size or width, so you will be arranging now the categories, and you will start with the lowest or the least number in the given data set. Number 5, after defining the classes, tally the observations to determine the class frequency. So frequency is as to how many times a certain data or a certain value occurs in the set of data. Next, we have step number 6, build additional columns to obtain other information about the distributional characteristics of the data. So these are the additional columns. So first column will be your classes. Second column will be the frequency. Next, we will be having the CB or the class boundary. So numbers that are halfway between the upper limit of a class and the lower limit of the next class. So this is very easy. Simply subtract 0.5 from the lower limit and also 0.5 from the upper limit. So I'm sorry, subtract 0.5 from the lower limit, then add 0.5 to the upper limit. Anyway, I will be explaining that further later. Letter B, another column, is the class mark or the midpoint, or usually denoted by CM. So this is the average of the lower and the upper limits of a given class interval. So all you have to do is add the lower limit and the upper limit and divide it by 2. Third one is the relative frequency or the RF. So this is obtained by dividing the frequency of a class by the total number of observations. So let's say a certain value appears twice. So that's 2 divided by as to how many numbers. If there are 10, that's simply 2 divided by 10. We have what we call as the relative percentage. The relative percentage is obtained by multiplying the relative frequency by 100%. Let's go back to my example earlier. If, for example, for a certain data, the frequency is 2 and there are 10 data or values in a data set, that's 2 divided by 10. So that's 0.2, and multiplying that by 100, that is 20%. Next column is what we call as the CF or the cumulative frequency. It is the accumulated frequency of a class, and there are 2 types. The first one is the less than CF and the greater than CF. The less than CF of a class is the total number of observations whose values do not exceed the upper limit of the class. And on the other hand, the greater than CF of a class is the total number of observations whose values are not less than the lower limit of the class. So let's have an example. Consider the scores of 40 students in the final exam in an elementary statistics course. Elementary statistics course. So these are the scores. These are the data obtained from the 40 students. First step is to determine or solve for the range, and the range is simply the difference between the highest and the lowest score. So the highest score is 112 subtracted by the lowest score, which is 44. Therefore, the range is 68. Second step is to determine the number of classes. So the formula for that again is K is equal to the square root of N. So N is the total number of values or the total number of data in a certain set. So since there are 40 students, there are also, of course, 40 scores. So there are 40 numbers in our data set. So that's simply the square root of 40. And again, based on the rule, the number of classes should be a whole number. So the square root of 40 is approximately or around 6.32. If you round that to the nearest whole number, that is approximately 6 or 6.0. Third step is to determine the class size. So, by the way, sorry, going back to step number 2, meaning there will be 6 intervals or 6 classes. Number 3, solving for the class size, meaning the boundary from the lower limit to the upper limit. So the formula is R divided by K, or range divided by the number of classes. Our range is 68, which we have solved earlier, divided by 6, which is the number of classes. That is approximately or around 11.3333. So since our data set is in terms of whole number, it is a whole number, or the data set are whole numbers, Therefore, our class size should also be a whole number. So that is approximately 11. So constructing the table, so this is the FDT or the frequency distribution table for the scores of 40 students in the final exam in elementary statistics. So as you can see here, there are 1, 2, 3, 4, 5, 6. Instead of 6, we had 7. Why? Because we still need to include the highest number here is 112. So we included a last interval here so that 112 will be taken into consideration. So there are cases that our class will exceed the one that we have solved. Now, here, we can observe our class size or the interval from the lower limit to the upper limit. It should be 11. So let's count. So lower limit is 44. Going to the upper limit, that's 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. So that is 11. The class size is 11. So that will be the same for the remaining class sizes. By the way, we started with 44 because 44 is the lowest score. For the frequency, you simply need to count as to how many scores will belong to that certain category. Now, for 44 to 54, there are 4 data or 4 scores under that category. So you can actually count or check. Now for the class boundaries, again, as I've told you earlier, that is simply subtracting 0.5 from the lower limit. That's 44 minus 0.5, that's 43.5. And for the upper limit, simply add 0.5. So 54 plus 0.5, that's 54.5. And you will do the same with the remaining intervals. Next, the class mark is simply the average of the lower limit and the upper limit. So let's have the second row. That's 55 plus 65, that is 120, divided by 2, that is 60. So you will do the same for the remaining rows. So simply add the lower limit and then the upper limit, then divide it by 2. For the relative percentage, simply divide the frequency by the total number of data. So that's 4 divided by 40, since there are 40 scores or 40 numbers in our data set. Then that's 0.4 times 100, that is 10. So same with the other rows. Now for less than CF, so how do we get this one? So for the first row, simply copy the first frequency. Now going to the next one, you have to add. So that's 4 plus 6. That will give us 10. So 10 plus 9, that will give us 19. 19 plus 7, that will give us 26. 26 plus 7, that's 33. 33 plus 6, that's 39. 39 plus 1, that is 40. So the last entry here in the last row should be n, or the total number of values in our data. So that's for less than. For greater than CF, it is done in reverse. So we start here at the bottom. So copy the frequency at the bottom or the last row, that's 1. Then plus 6, that's 7. Plus 7, that's 14. Plus 7, that's 21. Plus 9, that's 30. Plus 6, that's 36. The score, that is 40. So the pattern is going upwards. Okay. So that's it for FDT. Third one is presenting data with graphs. So data collected can also be presented using graphs. So aside from textual and tabular method, we have a presentation in terms of graphs. Common graphs constructed are the line, bar, and pie charts. So we have here qualities of a good graph. It should be accurate, simple, and clear. Accurate meaning it should not be distorted, or misleading, meaning the data being presented should be correct. It should not present any false information. Second is it should be simple. It should be straightforward, not loaded with irrelevant or trivial symbols and ornamentation. So if, for example, your data is about the scores of the students, it should just be the scores of the students, no additional or any information that is not necessary. Third is it should be clear, should be easily read and understood. So the moment a person or an individual looks at your graph, it should easily be understood that that is the data that you are conveying or presenting. So here we have examples. Line graph. This is useful for showing trends over a period of time. This is the unemployment rate in the Philippines from 2003 to 2013. So notice the trend as shown by the line graph. Second one is the bar graph. It consists of a series of regular bars where the length of the bar represents the magnitude to be demonstrated. This is the distribution of patients by blood type. So meaning here for B, there are 7. Also for O, there are 7 patients. For A, there are 6. For AB, there are 5. So see that the graph can easily be understood. So I think you're familiar with these type of graphs since you have discussed this one when you were in elementary and high school in your Aral Pan subjects. Third is the pie graph, which I know you are very familiar with. It is a circle, or a circle is divided into sectors in such a way that the area of each sector is proportional to the size of the quantity represented by the sector. So this is a distribution of faculty by department. So there are legends here on the right side. So the colors represent a certain department. So let's say this one, this is the social science department. This one is the science department, the representation. This is the prof ed department. This is the math department, and this is the language department. Next, we have a pictogram. Pictures or symbols are used to represent certain quantity or volume. So these are the preferred canteen of a sample of 50 high school students. So the smiley represents 5 students. So for canteen Y, these are the numbers of students who prefers a certain canteen. So each smiley should be multiplied by 5. So since there are 5, meaning 25 students prefers canteen or prefer canteen X. For canteen Y, that's 10. For canteen Z, there are 15 students. All in all, there are 50. So there are other graphical displays such as steam and leaf plot, the box plot, and we also have graphical presentation of the FDT. So FDT can be in tabular. It can also be presented in graphs. So these are the frequency histogram, relative frequency histogram, frequency polygon, and the ogive. So a frequency histogram, it is a bar graph that displays the classes on the horizontal axis and the frequencies of the classes on the vertical axis. The vertical lines of the bars are erected at the class boundaries, and the height of the bars corresponds to the class frequency. So whatever data is shown on the FDT, which is the table, that will just be transcribed or shown in the frequency histogram. So same with the relative frequency histogram, the frequency polygon, and the ogive. So that's it for my presentation on data collection and presentation. If you have questions, any clarifications, or any violent reactions, feel free to comment your questions on the comment section below. So that's it for this video. Thank you so much for listening. You take care always. Bye-bye for now.